Hello. Well, thanks for inviting me. Thank everyone for being here. I want to talk to you about, I guess, the importance of explicitly modeling inequality in IAMs. So I work mostly with the cost-benefit kind of IAM that Karen was talking about, but I think I have some comments that might be useful also for the detailed process kind of stuff. So I've been working on incorporating inequality into these models, maybe for 5-6 years now, and at least because I'm an economist, the reaction from economists has been mostly, well, from the sympathetic ones, it's been that it's actually not really worth the effort, and from the more hostile ones, it's been that it's actually it's incorrect and inappropriate to do so. So I'm gonna start off by just making a little case for when it is and when it's not appropriate to worry about inequality in such models, and then I'll give a couple of examples of the kind of work that my co-authors and I have been doing in this field. Okay. Okay, so obviously when we're trying to model complex systems, we can't model all the actions and outcomes that are going on, right? So we need some kind of simplifications to reduce the complexity of the model. And often the first thing to go is a description of the heterogeneity of the people making decisions, right? So we have these things, or rather we have this one specific simplification that we use in economics called the representative agent. And the representative agent is really just a decision maker. He's a decision maker, or she's a decision maker, whose choices are supposed to accurately describe the aggregate outcomes of the economy. And I'm going to call this the descriptive fiction of the representative agent. But also is a decision maker whose welfare is the correct objective to be maximized as a matter of economic policy. And that's a distinct but related fiction, which I call the prescriptive fiction. And of course, both of these fictions, they wouldn't be used so often if they weren't grounded in some kind of theoretical result that make them appropriate in many modeling contexts. And that's sort of the strength of the economic theory underlying it. It helps us understand when it is that it makes sense to reduce the complexity down to a single agent, and also when it's not, right? And so these theorems, in a very simplified sense, they tell us when is it that aggregate behavior can be described by the actions of a single individual, or rather by the actions implied by the preferences of a single individual. And then also they tell us under what additional normative beliefs or political structures maximizing the representative agent's utility, should he or she exist, can actually be viewed as sort of the correct prescriptive outcome. So again, just as an overview, I'll actually just, in a very simplified sense, relate the actual theoretical theorems underlying this, and explain when it is that these two fictions are meant to apply and when they come up against their limits. And then I'll show you some results in which my co-authors and I, we drop the representative agents for normative reasons in our models, but I think there's good reasons also descriptively in many, especially the detailed process models, to worry about whether the representative agent is doing the right thing. And at this point, I've seen quite a few detailed process models in which the representative agent isn't even used, so I don't want to make the case here that this is some kind of mistake that everyone's always making, but I've seen a lot in which they're not used, in which representative agents are used, and I think in many of them it might not be so appropriate. Okay? So the question is, when does the behavior of a single agent, from the point of view of the descriptive fiction, when does the behavior of a single agent describe the aggregate demand for all the goods that are being demanded? And the theorem, it's existed since the 70s pretty much, and it's due to a person called Gorman. It says that when preferences are homothetic and the income distribution is fixed and independent of prices, then there is an objective function that we can call the representative agent objective, and the aggregate demand of that objective function is identical to the aggregate demand of an economy in which there are all these individuals with homothetic preferences and a fixed income distribution. And that's really the only result we have. There isn't more than this. Unless this holds, we cannot accurately describe aggregate demand with a preference of one individual. Okay? So what do homothetic preferences mean? I mean, put most simply, they mean linear angle curves. So angle curves are the consumption expansion paths of any given good as income increases. So a linear angle curve means that the propensity to spend out of income is constant at every level of income. And so that the income elasticity of, let's say, energy demand, if we were modeling as energy, is 1. And it's 1 for all population groups. And so that's the implication of the homothetic preferences. And that may be true in many cases, or there are a lot of estimates out there for many goods in which approximately in the relevant range, angle curves are 1, or angle curves are linear, or elasticities are 1. But the additional requirement here is that even if angle curves are linear, if the income distribution changes over the time frame that you're doing your modeling, then that representative agent is also not accurately describing the demand. And so even though income distributions are known not to change very quickly, income distributions move very, very slowly, if we model things over decadal time steps or even centuries, then the income distribution will change. And so even if you've been able to ascertain that the angle curves are straight lines, over the longer time horizons, it will no longer be a good description of consumption once you've reached a point where the income distribution has changed, to be using the representative agent that was calibrated to today. And that's if angle curves are straight, which very often they're not. So the prescriptive fiction. So when is a good policy to take? Let's say it exists, the representative agent. When is a good policy to actually say, well, whatever maximizes the representative agent's objective is, as a matter of economic policy, the right thing to do. So again, the only theorem we have here, or rather sort of the combined theorem, is that again you need Gorman's result. You need the representative agent to even exist. Otherwise, you're not accurately describing outcomes, and so it doesn't really matter whether you like what the representative agent likes. But also, now the preferences have to be identical. Previously, preferences could be homothetic, but different individuals at different income groups could have different homothetic preferences. If you want to use it to claim some kind of a normative result, you need preferences to be homothetic and identical across the entire income distribution. And if that's the case, then the optimum of the representative agent's utility, it will accurately describe aggregate demand, but it will also be accurate once different parameters, different policy parameters have changed the economy, and that's why we need the sort of identical preferences. And even then, all that we get normatively is that the outcome is Pareto efficient. Now, Pareto efficient, every economist will know that, most other people will understand. All it means is that you cannot make anyone better off without making anyone worse off, but that's the extent of it, right? So that is all we have prescriptively in support of the representative agent. And so let's say all the descriptive aspects are satisfied, then when is Pareto efficiency appropriate? I'm just going to briefly, there's obviously tomes of welfare economics that bother with this, but there's one specific case in which it's easy to make the argument for just thinking about Pareto efficiency when we model, let's say, energy policy, right? And so that standard argument is due to Musgrave, and it says the following: a Pareto efficient outcome will maximize the total amount of resources. And so if we're worried about one part of the economy, is energy use being efficient, is energy use efficient, or materials use efficient, or something, then we could just, as a first pass, worry about Pareto efficiency. And then if somehow the distribution of resources is undesirable as it comes out of our model, then there's possibly more efficient tools for redistribution that other aspects of the political unit will worry about. And so under this framework, so this is the framework that gives the economist a free pass to only worry about Pareto efficiency, right? But it's important to state because it's often tacitly assumed and not really made explicit. And when you see this, you can already see why, for example, from the point of view of climate change, global climate change, the political entity that does part B of this process is simply not there. So even if in climate change it would make sense to model descriptively the entire energy and carbon consumption system as satisfying Gorman's theorem than to think that we could just worry about the Pareto efficiency of, you know, the global carbon stock and how it evolves over the next century or so, would somehow, would presuppose that there is some entity that is worrying about ensuring the Pareto efficiency is somehow also complemented with some kind of distributive goals. And it's quite clear that that's not the case from the point of view of global climate change, right? And so that's the sort of point of departure, let's say, from some of the work that, that my colleagues and I have been doing. Let me see how much time I have. Okay. Okay, so let's look at a particular implementation of this in a cost-benefit model that I've worked on. So just review, we in general in cost-benefit models, we routinely discount future damages on account of the future average income being higher. We know that in a century, the average income of the world, bar some very, very unlikely outcomes, is going to be greater than today. And so marginal damages that accrue in a century are going to be, in some sense, valued at less, right? And so if this weren't so, if we didn't sort of value damages, let's say, less on account of average income being higher, then the social cost of carbon would be much higher than the numbers that we know. In the DICE model in particular, in the latest iteration of it, if you look at it, $1 per capita of abatement today is only invested if it avoids $36 of per capita damage in 2100. So that's a factor of 1 to 36. That's a big discount rate, right? And that discount rate is split according to something called the Ramsey equation, but just to say that if the global average income in 2100 were the same as today, then that discount factor would only be 3.5 to 1. So the amount of discounting that we do purely on account of pure time preference, as we call it, in the DICE model, not everyone even bothers with pure time discounting, but in the DICE model, according to Bill Nordhaus's chosen parameters, we'd be discounting a century down the line by only 3.5 to 1. That's not such a big factor. So the remaining factor 10 to get to $36 to 1 is on account of the normative stance that since the future will be richer, there'll be